Okay, so all I want to talk about is a very nice fact for the minimal polynomial and the matrix, if it's invertible or not. As you can see, there is a theorem in linear algebra that says that if A is invertible, if and only if, the constant term in the minimal polynomial is not zero. Remember that the minimal polynomial is the polynomial with the minimal degree that annihilates the matrix if you substitute the matrix into the polynomial. So it says that if you have an invertible matrix, it must be that the constant term in the minimal polynomial is not zero. Let's see why it works. Just what we are going to do is taking the constant term on the minimal polynomial. Let's look on how the minimal polynomial looks like. This is our minimal polynomial, the general form, okay, and this is a0, the constant. We say that if a is invertible, it must be that this is not zero. The constant term in the minimal polynomial is not zero. Let's see why. Because if a0 is zero, you can look at the equation like this, right? Because the constant term is zero, so it's not here. If so, you can take out a, right? And you get to this equation. But if you get to this equation, if a is invertible, what should not be, because a0 is 0, we said that if the constant term in the minimal polynomial is 0, it must be that a is not invertible. A is invertible only if this is 0. Now, if we assume we are wrong and a0 is 0 and the matrix is invertible, we will get to a contradiction. If a0 is 0, again, you can look at the minimal polynomial in this case when you substitute a, and remember that the matrix always annihilates its minimal polynomial. Now take out a, you get this one. Now if a is invertible, you can just take the inverse, left side inverse from both sides and get to this one. And what did you get here? You get a polynomial of degree k minus 1, which is less than the degree of the minimal polynomial, which what it does, he annihilates the matrix, which should not happen, because the minimal polynomial by definition is the minimal degree polynomial that annihilates the matrix. So we got here that if we have a constant term which is 0 and we assume that the matrix is invertible, we get to a lesser degree than the minimal polynomial that annihilates the matrix, which is contradiction for the definition of minimal polynomial. Therefore, we conclude that if the constant term in the minimal polynomial is 0, the matrix cannot be invertible. And that's it.